Hello guys, I have been told to give the solutions of two of the questions from the exercise 3D. Yes, so the first one is the question number 14 and the second is the 20th question. Both the questions are of the same kind and they are very important questions. You will find many such questions in your past papers. So I really appreciate the student who has asked for the solution of these questions. Okay. Now the question says a ball of mass 3 kg is rolled with initial speed 4 meter per second up a slope at an angle 10 degrees to the horizontal. Okay, so I'm just going to draw this. Suppose this is your horizontal and here is that inclined surface on which we have rolled our ball. Okay, so obviously when you're going to roll it up, you have to give it an initial push and that will give it the initial speed. So the initial speed over here is 4 meter per second. So this is 4 meter per second. That is the initial speed over here. Okay, and then he says find the maximum distance up the slope the ball reaches. Now please remember, whenever we ask to find the maximum distance or the maximum height, so we should remember that when an object reaches the maximum speed, the maximum distance, there the speed is 0. Okay, so let's suppose it started from the point A and here is the point B. Okay, so we shall assume that when it reaches the point B, here the final speed is 0. Okay, so this is 0 meter per second. So we have to find the maximum distance. We have to find the distance AB. So I'm going to show that ball over here whose mass is 3 kg. Now remember, you have to show, I'm just going to show its weight vertically downward. So this is the weight which is, I have to mention it as 30 newtons. Okay, and now please remember that when you're rolling this ball up the slope here, so there is no upward force in the ball. You've just given this an initial push. There is nothing pulling this upward, but there is the component of the weight of this ball that would try this ball not to go very high up the plane, and it would try this to come down the slope. Okay, and then there is obviously the frictional force over here, but he hasn't mentioned the frictional force. We're just assuming that this inclined surface is a smooth surface. Okay, now I'll be resolving this weight parallel and perpendicular to this slope, which is basically the direction of the motion of this ball. So remember, we keep our pencil over here. So you draw a line perpendicular, okay, to this surface like this, and then this one is parallel to this inclined surface. So this angle is 10, so this is going to be 10, and this is going to be, this component of the weight is going to be 30 sine 10. This component is going to be 30 cos 10. This is used to determine the value of R, which is not required right now. Okay, that will be required inshallah in the next chapter. So there is no forward force over here. Okay, so I'm just going to mention this. There is 0 Newton force, but there is a force, downward force, 30 sine 10, which is trying this ball to come down this slope. Okay, so now we have to find the maximum, the distance AB. So we have the initial speed, we have the final speed, we have to find the distance, and our darling formula F equal to ma, this formula will give us the acceleration. So there is no forward force, there is a backward force which is 30 sine 10, and that is equal to ma. So the acceleration is going to be minus 10 sine 10. I'll not be finding its value right now because this is not the answer required. I'll be using this into the kinematics equation 2as, that is equal to v square minus u square. Okay, so we have the this is going to be 2, this is into minus 10 sine 10. The final speed is 0, the initial speed was 4, that is 16, its square is 16. So this will give you, oh, I forgot to write s over here. Okay, so this will give you the required distance AB if you use the calculator. Okay, in B part, he's saying what assumptions have been made to answer the question. Obviously, we've taken this ball as a particle which is moving up this plane. And by the way, I have also made another assumption, that is that this slope over here is a smooth one. Okay, now I move to the question number 20. Okay, now we are on to the 20th question. It's the same kind of a question, but a bit challenging. It's a PS, problem solving. By the way, it's a batamizi to ask me to solve such a question. You should try to solve it yourself. Okay, you should keep trying and trying and trying until you are successful to solve it. Anyhow, since I myself had given you the offered you to ask any questions, so that is I'm going to solve this question number 20. A car of mass 1200 kg arrives at a steep upwards slope of length 130 meter. Now, just like the previous question, this time we are given the length of this, we are given the S, which is 130 meters. Okay, and this is inclined at 34 degrees. So this angle over here is 34 degrees. It arrives at this point with the speed 12 meter. Like we're given this initial speed, which is 12 meter per second, and now I'm just going to assume that here is that car. Okay, and I'll be showing its weight. You should always do this whenever you have the inclined plane. Okay, this is now going to be 12,000 newtons. Okay, now it says there is air resistance of 100 newtons. Okay, so I'm showing this air resistance. Obviously this car is going up, so the resistance is going to be opposite to the direction of motion. And then it says find the minimum force assumed constant the engine must provide for the car to reach the top of the slope. Okay, so this is let me assume this is the driving force. Okay, and I'm going to assume that when it reaches here, since he's asking for the minimum force required, so we're going to assume that it just reaches the top of this steep section of the road. Okay, so again we shall be resolving this weight. Okay, we should always do that. So I'll be doing it like this, and this one. There is a right angle. We don't need R right now. Again, we are assuming that there is no friction going on between the car and the road. Okay, if this is 34 degrees, this is going to be 34 degrees as well. Guys, you should be very quick and very good in writing these components. This is 12,000 sine 34, and this is 12,000 cos. We don't need this 12,000 cos 34 right now, because I have told you many a times that this is used to determine the value of R. Okay, now, so this is up to you. Either you find the acceleration first or you find that force first. So I'll be finding the acceleration first using the equation that is 2as, that is v square minus u square. So this is going to be 2a into 130. That is, I'm just taking this as 0, and this is minus 144. Now this gives me the acceleration, which is, I have calculated this already. It is minus 36 over 65. Okay, and now comes our darling formula, that is F equal to ma. Okay, F equal to ma. Now there is the forward force, that is what we have to find. Now guys, look at this. Can you tell me how many forces are here which are involved in this car's motion up this inclined plane? I mean, the force is parallel to the direction of the motion. Yeah, This is the first one, the force provided by the engine of the car. This one is the air resistance, and this is the component of the weight. This will obviously opposite to the direction of the motion. Suppose if this car was coming downwards, then this weight would be added with the driving force. I hope you can realize that, imagine that. Okay, so now this forward force we have to find, and there are two forces backward. One is the air resistance, other is the component of the weight, that is 12,000 sine 34, and that is equal to MA. That is going to be, where is mass? Yeah, the mass is 1200, and I'll be using the acceleration, that is minus 36 over 65. So guys, this gives me the driving force. So this forward force is 6,145.7 newtons. If you write this correct to three significant figures, this is 6150 newtons. So this is the minimum force. If car's engine provides this force, this car will just reach the top of this hill. Okay, thank you very much. Keep asking your questions, the questions where you face problems, and stay blessed. See you in the next video. Allah Hafiz.